we'll look at programming paradigms, then we'll discuss problem-solving strategies, and then we'll look at essentially how problem-solving is done generally and how it is done in programming. And then we'll look at variables, data types, typecasting, and constants, and what we term as named constants or literals. So let's have a look. Now, when we talk about programming paradigm, we are looking at, or we are trying to refer to, a set of distinct approaches or styles that can be adopted in programming. So for
The mic is muted again.
okay, give me a sec. Hello, can you hear me?
Yes,
Hello?
sir.
Yes, sir.
I'm trying to go back again and see if we can. Is it muted?
No,
No,
sir.
sir. We can hear you, sir.
It's okay. It's okay now.
I'm not touching it, so I don't know why it's muted. Okay, nevertheless, okay, so programming styles describe formal ways in which you can write various programs. Okay, so just like how you have letter writing, we can have formal letter writing, informal letter writing, and even with the formal, we have a way or a style we write letters that are going to maybe a particular kind of authority, maybe semi-formal, and those kinds of things. So also in programming, we can have the various approaches. The approach is important, okay? The approach tells us the mode or the method or how what we are about to do or how we are going to approach the problem. Now, the approach also governs or lets us know how the problem is going to be broken down, okay? Because the problem needs to be broken down into solvable units. And the type of approach we adopt shows us the kind of solvable units we are going to use. For example, in functional programming, the solvable units are immutable methods or functions. Okay. In object-oriented programming, the solvable units are tasks, okay, or objects. Okay, so the approach is very important. Now, the approach sometimes depends on the particular kind or type of problem that we have encountered. So, for example, if the problem is a web-based problem, there's some approaches that have been developed over the years, specifically designed to help us understand and solve web-based problems. Okay, and then there are some approaches that can help us design and solve desktop-based problems. And then there are some approaches that can be used for mobile application development. Okay, some of them are interchangeable. For example, object-oriented, you can interchange them between mobile and desktop and the rest. But there are some which are not interchangeable because or based on the size or the platform the problem is running on. Okay. Now, let's go to the next. So generally, you find out that if you write a particular program and you don't have any mechanism of approaching the program development, you are doing what we call unstructured programming. Okay. So I did not bring that over here because basically it's the simplest type of programming development approach. But it's not even an approach because it's when you loosely write your program without any structure to it. Okay, it is very bad way to write programming or programs, and we advise you not to approach program development using unstructured programming. Okay, if you are writing or demonstrating simple programming concepts. Yes, someone's hand is up. Hello. Can you hear me?
Good morning.
Yes.
Yes, please. Please,
Hello.
I want to put the class. Hello, sir.
Yes, your.
Hello, sir.
Yeah, I cannot hear what you're saying.
Now, from IT class.
Okay.
Hello.
Please, your question. Oh, we have already spent enough time here. Your question.
Hello, sir.
Can someone hear him?
No, we can't hear what he's saying. It's
Okay,
not
then let me
sounding clear. We
continue.
can't hear.
Let
I'm sure
me
he's
continue.
having
Please,
issues with
please.
his network.
Okay, allow me to get to some point, and then I'll ask you to ask questions. Okay, but don't interrupt the class with the questions for now. Okay.
All right, sir.
Okay, so unstructured programming is when we have or we write programs without a clear structure or a clear idea about how the approach is going to be, right? So like I told you earlier, programming. Oh, hello. Hello. Hello.
Please, sir, we can hear you, sir.
Am I muted? Hello.
No, sir. No, sir. We can hear you, sir.
No, sir, we can hear you.
Okay. I can hear other people
hear you,
talking.
sir.
That's why. Okay. So unstructured programming is not desirable. Okay. Now, when you want to structure, you can begin by looking at something called procedural programming. Okay. Procedural programming in some form is. Oh, sorry. Okay, so procedural form in some programming is what we term as structured programming. Okay, now procedural programming focuses on us writing the code or the instructions so that they execute step by step. Okay. Or how we in Ghana we refer to as one after the other. Okay, I think in Ghana that's how we normally do that. Okay, we say step by step instead of saying step by step, we say one after the other. Okay, now when we try to put the program or group parts or elements of the program so that the groups are organized in a way that they execute or they do things together. Okay, that is what we term as procedural programming. Okay, in procedural programming, key concept in there is what we call procedures. Okay, some programming languages refer to these procedures as function. Well, they are not functions, but they look or they operate as such. Okay, now we will take our time in this course. This is our main focus of this course. We will take our time and break down procedural programming and the key features of procedural programming. So, like I said, one of the key features is that the programs you organize or write as procedural programming, they run step by step, right? One statement, then another statement, then another statement, then another statement, and so you notice that the procedures run step by step. Now, most times in procedural programming, we write them from top down, okay? So it is such that the code is written like this. And how the procedural program runs is that when the compiler begins to run the procedural program, it begins from the very top and begins to run the code from top to bottom. Okay, that's what we mean top-down approach. Okay, then usually procedural programs are for very small types of programs or very small program code. And for beginners like us, this is the first or most widely used approach that we may opt for. Okay, so the key situations where you can adopt or use procedural programs is when you have or you are working with small programs. Okay, so if the programs are just a few hundred lines of code and you just need some demonstration, you need to prove something, show something, let it run from top to bottom. Every time you run, the whole program is compiled. Then we go in for procedural programs or programming style. Okay, the other programming style we might go in for, which is not procedural programming, is something called object-oriented programming. Okay, or we refer to it as object-oriented design sometimes. Now, how object-oriented design works is that we organize the code or the entire project around something we call objects. And objects are usually organized into what we call classes, okay, in the code. Okay, so when we get the problem and we have to deduce how to solve the problem, we break the problem down into its constituent parts. And those constituent parts must be nouns. Okay, the nouns within the problem are what forms the basis for the objects that we create in object-oriented programming. Now, because we organize the code around objects, we have features, or we can support features like encapsulation. We can support something called abstraction. We can support something called polymorphism. We can support inheriting from other objects. And then, like I said, every object, because they are nouns, they have two important things. They have attributes, and then they have what we call methods. Okay, so attributes and methods. And these are the things that allow us to write the code so that they only run when a particular object is called. Okay, now if you are writing very large programs, or if the programming is very complex, you might or you may likely want to use object-oriented program design. Okay, the other programming design which is fairly popular is a program paradigm or programming paradigm called functional programming. So in functional programming, what we tend to do is that we break the program down into immutable functions. Okay, we organize the program so that instead of writing everything together like we do in procedural programming, we organize it so that parts of the program are organized into units called functions. And those units called functions can be used in other programs. Okay, So, for example, instead of writing everything in one and having everything run all the time, if we need to write another new code, there's no need to rewrite the part which we already have. All we need to do is to do something called a function call and call the parts which already exist into the new program. Once we write those parts, they become part of our library and we use them all the time. We normally use these things for things like mathematical computation and programs which involve parallelization, what we call parallelization, okay, where programs can do multiple things at the same time, okay. And then we have something called reactive programming. Reactive programming is used when we want to build data kind of programs. For example, if you are building something in data science with Python or with R, you might do a form of programming where you are responding to the changes that you apply to the data. Okay, so that type of programming is entirely different from functional programming and entirely different from the other two we have discussed earlier. And like I said, it is useful for data processing and UI development. If you are working in TK Tinker with C++ and co, you might do reactive programming, okay? Then, for those of you who are familiar with databases, SQL, and co, you note, and web development, you notice that you use a language called CSS, okay, or HTML. And the way HTML is structured, how you write the tags is what you see on the web page. Okay, so we call that kind of thing declarative programming. Okay, now if you're also familiar with SQL and databases, you know that what you desire, you state the output or the outcome. For example, if you want to see all of the results from maybe a particular database, what you would do is that you call all of the results by stating a line like select all from maybe student database. Okay, now this type of way to write programming statements is referred to as declaration. Okay, so we know exactly what we are looking for by writing how the output should be presented or how the output should be given to us. Okay, so that type focuses on what should be done. Okay, unlike some writing maybe a web program or writing maybe a desktop application, SQL statements and HTML statements tell the computer how to present or what to present as the result for a particular application. Now, the key features is that we define the answers based on the declarations that you present. And you can check how the program statements are written and describe the desired outcome from the program statement. Okay, so so here, for instance, we know exactly what will be returned based on the way it is written. Okay, we know that this is a keyword. We know that this is also a keyword, and so we are returning everything, right? We are returning all from a particular database over here. Okay. Okay. Then we have a programming paradigm called logical programming. So in logical programming, we define the program statements based on logic and facts, okay, or what we call rules. We use things like predicate logic, first order logic, and code to try and define the programming language statements, right? Language or programming languages which are commonly used logical programming include programming languages like Haskell, programming languages like Prolog, like how do you call it? So ML and Co. These are the programming languages that use something like that. So they have what we call a knowledge representation And once the programming language has this knowledge representation, the only way to write your programming language statements is to know this kind of logic, true or false, Boolean algebra, De Morgan's logic, and those kinds of things. And you use those kinds of rules to try and return the answers or the results you want from the programming language. Okay. Before I proceed, okay. Sorry. Okay. So before I proceed, we have discussed a couple of them. Now, what I want to also state on the record is that there are so many other ones I have not included here because I cannot write about everything. Okay. So there's one called visual programming. I don't know how many of us have used or have done any programming in Visual Basic. How many of us have done any programming in Visual Basic? Hello?
Yeah, here's him.
How many of us have done any programming in Visual Basic? Okay. Nobody? Okay. Okay. But there's a programming language called Visual Basic, and basically what it is that you have screen elements like boxes. Most of you know Photoshop, right? Adobe
Yeah.
Photoshop.
Yes, sir.
Yeah.
Draw.
Yes, sir.
Okay, so the way you
That's good.
grab something from the canvas, you grab something from the toolbox and place it on the canvas. That's the same way you do Visual Basic. Okay, so Visual Basic has a toolbox which you can grab something and place on the form and then write the code behind it. There are visual elements and there's a coding element as well. Some of the things you see in Visual Basic, you can actually write them out as code, or you can simply pick it from the toolbox and place it directly on the canvas, just like how you are doing Adobe Photoshop. Okay, so that's basically how the Visual Basic or visual programming language also is. And then there's also another paradigm which is very popular. It's called DOM, Document Object Model. Okay, so document object model is also used for web program design or web programming. Okay, and it's fairly easy to learn. It uses something called a hierarchical system, and it is used on web pages which have maybe HTML and CSS. They are those kinds of raw web pages of sorts. Okay, and CSS uses it all the time. Okay, and then we have another one called MVC, a model view controller. So model view controller as well is also used on web page design or web page apps, and it can also be used on mobile application development as well. Okay, so please take note that if you see or hear any of this in the future, it's not that Mr. Bachman has not mentioned it, but like I said, we cannot exhaust all the knowledge. There are some that we will never be able to mention due to limited time or limited space to discuss these issues. Okay. If you have any questions, you can raise up your hand. But whilst you are doing that, I will continue with the lecture. Okay. Now, programming, the whole concept of programming is so that we can solve problems. Okay. That's the whole concept of programming, so that we can actually solve problems. And in order to do programming, after knowing the various paradigms that need to be used to do programming, we need to also know exactly how to select the particular paradigm. So which one do we go in for? Which one? Do we go in for object-oriented? Do we go in for procedural programming or structured programming? Do we go in for declarative programming? What do we, or what should we go in for? Okay, now what we should go in for primarily depends on the domain or where or which area the problem is coming from. Okay, so for example, if the problem is very complex or it is large and it involves some hierarchy, maybe it involves some graphical user interfaces, and it is going to be used on business applications, or it's going to be used in very large environments, then object-oriented is a good option. Okay, so object-oriented is suitable for those kinds of problems that have this kinds of feature. Okay, so if the domain is like that, then we know that the best option is object-oriented. Now, if the domain too is mathematical, it involves processing, it involves mathematics, it involves concurrent programming where we have to do two or more things at the same time, then the domain of such a program is what? Functional programming. Okay, so that is the case. Then if the problem also involves AI, okay, or it involves some form of querying where we have to query a knowledge base, then obviously the solution will be better suited for logic or declarative programming. And so one of the key features, or one of the key reasons for choosing a particular problem is based on the problem domain. Another key feature is the size or the scale of the problem. Already, like I've discussed, if the problem is very big, then it should be object-oriented. If it is very small and it is limited in how it works, then it should be procedural programming. Okay. Should be procedural programming. Okay, so one of the hold on, give me 1 minute. Boss, I use the phone. Okay, so if the problem involves like I said, it's simple and it's low level and it doesn't require so much moving parts, then you go in for procedural or imperative programming. Okay, then sometimes too, the kind of solution you pick involves or depends on the team that you are working. But he just picked the key. I don't have the other one. And it's just it's one more book. Because this one. Okay, sorry. Hello, can you hear me?
Yes, sir.
Yes, sir. We can hear you.
Okay, so sometimes to the expertise of the team, okay, the people who are working, for example, if someone on the team only knows object-oriented and the other person who is leading the project, they will obviously push the team to use object-oriented, okay? If someone on the team knows functional programming, okay, they will push the team to use functional programming, okay? So sometimes to the expertise of the team determines which of the paradigms the team will go in for, okay? And then also the language is also important, okay? The ecosystem, the support you get. So for example, if you go and choose Java can only do object-oriented, okay? So because you chose Java, you are forced to use object-oriented when you are designing your application. Maybe you want to choose Microsoft SQL, okay? And because you are using Microsoft SQL and it's SQL, you are forced to use declarative programming, okay? Sometimes to the choice or the desired performance of the application is also one of the key drivers. Other times too, the problem itself naturally tells you which kind of paradigm that you can go in for. And then sometimes, or in most cases, most programmers will use multiple paradigms. They will try and adopt features from different paradigms so that they can enjoy the advantages of each of those paradigms. Okay, so those are some of the key questions or key issues for the programming paradigm and how a particular paradigm is chosen. Okay, now when we all know that problem solving is a very important part of programming, and so we want to look at how specifically we adopt problem solving in or during programming. Okay, now in order to do that, we need to understand how we do it in general. So in general, how do we solve problems? In general, I know that most of us, in order to solve problems at home or maybe facing us in school or in some place, the first step you do is first and foremost, you want to understand the problem. Most of you will go ahead and try and understand the problem. Then I'm sure most of you will go ahead and now devise a plan for solving the problem. Okay, then I'm sure after devising the plan, you want to carry out the plan to see which one is the most ideal. Maybe you have 2 or more plans, so you want to run the plan or you want to carry out the plan to see which one is the most suitable approach. Then the next or most important one after that is to test whether your plan works or your plan did not work. Okay, so generally this is our problem solving strategy. We call it the general problem solving strategy, and we adopt this most often in our program or in our general lives. Okay, now in programming there could be different kinds of problem which would necessitate the tweaking of this problem solving strategy. Number one, for instance, we can have problems which require or which use a strategy we call divide and conquer. Okay, so most of us, when we have a problem and it's a very large problem, we try to find the answer to the very large problem as it is. But there are some problems in IT and computer science which require that we break the problem into smaller chunks. Okay, so what we normally do will be to split the main problem into sub problems. Okay, and then once we break that problem into sub problems, we can solve them independently and put the answers back together. We call this type of approach divide and conquer. Then we have another approach in programming or problem design we call dynamic programming. So in dynamic programming, instead of solving the thing at large or as it is, and remembering maybe the answers, we try and solve the problem and keep all the small solutions. Okay, we try and solve small parts of the problem and keep the answers, so that in the future, if we need to go to a big problem which requires the small solution, we can simply go back and take that small solution without having to resolve the problem again. We call that idea dynamic programming. Then we have problems which can be solved using a strategy we call greedy algorithms. So in greedy algorithms, what normally happens is that we make the local choice for an optimum. Most of us have seen this before when we were doing our JSS or secondary school. We encountered maybe graphs like this. And then if you remember, graphs like this have what we call the the local optimum and the local minimum, right? The local maximum and the local minimum, right? But along the graph, there are other local maximums and local minimum. So what happens is that for a greedy algorithm, we only choose the one which is close to us. So for example, if we are here, we will choose the closest one to us and we'll pick that as an answer. But there could be other answers to the same problem all along. Okay, but a greedy algorithm will choose the closest one and ignore the other ones. Okay, so that's what we mean by greedy. It's always choosing the local optimum. Then backtracking is an idea which allows us to go back to a previous solution or to go back to a path that we chose in the computation which was promising. So, for example, if we are solving a problem and we reach a junction, which it goes 3 or 4 weeks, okay, and then we go one way and we notice that the way we have gone is not going to lead us to the solution. What backtracking allows us to do is to go back and then choose a different path, and then we can go back and then choose a path which will lead us to the most promising answer. Okay, so that's what backtracking, the idea is. Then we have heuristic. Heuristic is an idea that we can find the solution by estimating what the solution is, and then trying to recompute all of the inputs so that we can get close to the estimated answer. Okay. Then pattern recognition is what we use to identify recurrent structures. So if I give you a sequence of letters A, B, B, A, and then A, B, 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 A, and I have to find the places where in these two sequences they are similar, you will struggle because it's a very long sequence. But pattern recognition helps us to find the places that are the same in both patterns. Okay, that's what pattern recognition is about. Okay, now in software development, we can use these approaches, right, along with our understanding of the general problem solving strategy to answer or to solve a particular software based problem. Okay, now remember we said that in the general problem solving strategy, the first step is to first of all understand the problem. Now, second step is to devise a plan. Third step is to carry out the plan. The fourth step is to test whether the plan worked or not. In software engineering, we adopt the same thing, but we edit it or we modify it so that they can suit software development. So in software design, number one, what we do is that we do what we call planning. Okay, so in the planning stage, that is where we try and define our goals. We specify something called the scope. We determine what resources will be used by the project. Then we try and gather the initial requirements and we perform what we call an analysis of the entire project or program. Then we do cost estimates, we try and set the timelines, we try and allocate responsibilities and code. Then we do what we call requirement analysis. Here, the requirements that you have gathered, they are not enough to build the software. So what you want to do is to go further and understand if there are more requirements to try and reach or get those or gather those requirements. If there are no more requirements, we try and now modify the ones we have so that we can better use them to design the software. Okay, then the next step after the requirements is to do what we call the project or program design. So here we do architectural drawings of the software that we want to build. So just like how the architects will draw a building floor plan before they go and lay the first block, the software developer will also draw the plan of the software on paper before they go and write the software itself. So this is where we do that software design. Okay, then after designing the software and correcting all the designs using various tools to understand whether the design is good or not, we can go ahead and now do the implementation. So the implementation allows us to write the actual code, to delve deep into the writing of the code. What is the drawing saying? Can we replicate the drawing into coding? Okay. Then after coding, you want to make sure that your code works. So you do what we call testing. So you test the software as simple single units, or we test the software together. And then we now go and give the software to the client and let the client also run the software. So we call that deployment and maintenance. most of you will be there, and then you get you'll be there, and then you get updates, right? You get updates for your WhatsApp, updates for maybe your apps that you have on your phone, because it is part of what we call the maintenance phase of the software. After designing and writing the code, you need to always maintain the code, regularly update it so that the code will be up to date. Okay, so that is the key thing over here. Now, before we go on, is there any questions about what we discussed? Generally, problem-solving paradigms, paradigms in programming, and then general problem-solving strategy. Any questions? Yes. Hello, my friends. Any questions so far?
Hello, sir.
Yes, PM.
Yeah.
Please make it short and very straightforward. Please go on.
Yeah, hello, sir. Please have a good morning.
Please make it short and straightforward. Please go on.
Hello.
Please go on.
Okay, sir. Please, I want to ask if among all these techniques in solving the problem, you have a particular one that supersede all, or you need a particular technique for a particular problem.
Oh, like we said, I don't. You see, when we finished, we were discussing how to select an appropriate one. You see, so we discussed several reasons. Okay, and we said that the type of problem. So every kind of problem, or most types of problem, desire a particular kind of paradigm. Okay, so there's not one that supersedes all, but it is based on the type of problem, the scale of the problem, the team expertise, the language ecosystem, performance, paradigms, and then sometimes you can mix a couple of them. Okay, but the most popular one that everybody uses, or everybody at least knows, is object-oriented programming. Okay, and structured programming. Okay, but the most popular one is object-oriented. It's very, very popular. Almost every programmer you meet at least understands what we mean by object-oriented programming. Are you there? Are you satisfied?
Yeah, yeah, me, I'm okay, sir. Thank you.
Okay, you're welcome. Okay, so is that another hand?
Yes, sir, please.
Okay.
So I wanted to know if there's a single programming language that supports multiple paradigms.
Oh, currently or these days, many programming languages support multiple paradigms. For example, Java, they say is object-oriented, but Java also supports functional. Okay, C++ is functional, but C++ is also object-oriented. Okay, so a programming language can support multiple paradigms.
Okay, sir. Yes, sir.
Yeah, Python, for instance, is structural or procedural, but it can also be object-oriented. Python can also be declarative. Python can also be imperative. So it depends on what you are using it for and how you are writing it. Okay, so in the absence of those questions and having solved that, let's look at what variables are. So you often hear me use the term or the word variables in our class. And whenever I refer to variables, I am referring to, I'm referring to a container. Okay. For, I think in Ghana, I think the term we normally would use is called container. Okay, so when I say container, I think everybody understands what a container is, right? So in programming, okay, variables refer to a memory allocation, okay, or what we term as a container for holding a value. Okay, so for example, I want to store the number 2. during the running of my program. How do I store the number 2? How do I tell the computer that, hey, computer, keep this number so that whenever I need it, I'll come for it? So you put the number 2 inside a variable and give the variable a name. Okay, so that is what basically a variable is. A variable is just a container or a way to hold some value during the running of the program. As you are running the program, the variable will hold that value, and then will keep or store that value until you finish running that program. Okay. Now, usually what we do is that because we can hold multiple variables at a time, in order to differentiate one variable from another variable and another one, we normally have names. So we give the variables names. Okay. So variables have names, and the names help us to differentiate one container from another container. And then sometimes too, the computer doesn't understand what is inside the container. Okay, so we need to tell the computer what is inside. And usually how we do that is to specify something called a data type. Okay, so a data type tells the computer the kind of information, okay, the kind of information that will be stored. Okay, so the data type describes or tells the computer the kind of information, whether it's a number, whether it's somebody's name, whether it's somebody's age, whether it's a date, whether it's what have you. The data type describes that. And the variable is the main container. And the variable needs a name. So we will be describing or discussing those 3 important things. Okay. So like I said, in programming, before you can use a variable, you must create it. So variable declaration is just creation of variables. Okay. In programming, when you create the variables, okay, we call it a variable declaration. Okay. Now, the variable declaration statement tells the computer the type of variable and the name of the variable. In programming, the name of the variable is called an identifier, and the type is called data type. Remember, name is called identifier, type is called data type. Okay, so please take note of that. Okay, now, apart from the name and the type, programming languages also keep track of the size and the contents of what is stored in memory. Okay, so please take note of that. We'll come back to that. Now, when you want to create a variable, okay, an example is what I'm giving over here. So in this example, I'm showing you ways in which we create 2 or more variables. So for example, if I want to create a container called price, okay, this container will hold the price of something, maybe the price of onions or the price of a tin of milk or something. If I want to store something in there, then I will have to tell the computer by writing int and then the name of the container price. Now, what actually happens in memory is that when I write int price, the computer creates a container for holding the price. In the future, I can simply write price equal to maybe 12. And then what the computer will do is to put 12 inside the container. I hope you understand what I'm trying to help you to see. Okay. Then also, for example, if I'm a teacher and I teach several courses and I want to store the name of the course inside a variable in a program, then I will tell the computer that, oh, what I want to store is a string. Okay, notice that these 2 things, string and int, are different. Int is for integers, which are numbers, and then string is for words. So if I have example, Kwame. Kwame is a string, but 12 is an integer. Okay, so that is a key example. Okay. Okay. Now, if when you create the variable like I've written over here in this tool, we call that variable declaration. Now, declaring the variable alone is good, but it's not really helpful. Variable declaration just creates the box. Now you must put something into the box. So in order to put something, we call that variable initialization. To initialize the variable means to put something inside the variable. So an example, I'm putting 800 inside a variable called salary. Remember, I'm putting 800 because the data type of the variable is what? Integer or int. So I can only put whole number. Then here I'm putting a character A into the variable called my grade, and then which has a data type of character to a single character. Then another example, I'm putting the number 14.55 into a variable called your rate. Okay, so the variable name over there is called your rate. And then the data type of that variable is what? Float. Then next example, I'm putting a variable called, I'm putting into a variable called your name, the name Juanita or Juanita. And remember, if I have more than one character, it's called a string. Okay. So these are all examples of initializing a variable. And then when you create it, we call variable declaration. You can also create the variable and initialize it at the same time, like I've done in these examples. So these ones, you create and initialize them at the same time. Okay. Then you can also create them and then later on you can initialize them. Okay. So all of those are also possible. Now, okay, there's a question. Yes. Hello, please go ahead.
Hello, sir.
Yes, sir.
Okay, sir. So, please, the first one you said, the int, that is the integers one is only numbers, and the strings is all the names or is let me say name or anything. But the second one, that is initializing the variable. The A, does it mean say if there's only one word? If there's only one word, it doesn't categorize to the strings side.
Thank you very much. Thank you. So that's a good observation. I'll come and talk about data types very shortly. Okay, that will be in another lecture. But like you are saying, this is called character. Okay, let me undo that. This is called character. This is called string. Notice that this one only can take one character, but this one can take more than one. So that's the key difference. When it is one, it's a character, but when it is more than one, it's a string. Does that help
All
you?
right. Thank you, sir. Yeah, yes, please. Yes, please.
Thank you. Good observation. Thank you. Okay. And then, so now let me talk about naming, or what we call the name of the variable, what we call the identifier. Okay. So the name of the variable or the identifier is or refers to the name of the variable. Okay. All programming languages have a way you use to name a variable. Okay. But the general understanding is that if you want to name a variable, you should use any of the alphabets from A to Z, whether capital or lowercase. Okay. Most programming languages also accept numbers, but the name cannot start with a number. Okay, so please remember that the name of a variable cannot start the number. Some programming languages accept underscore, others accept dollar sign, some even accept hyphen. Okay, but the catch is that the name of any programming language variable must be one word. Okay, even if there are more than one words, you must combine them with one. We must combine them together make one word. Okay, so I'll show you some examples. Okay, so generally I have some advice for you. The advice I have is that when you are naming variables, try and use descriptive names. Use names which mean the thing you are trying to do. So for example, if I want to take your name, I want to take name. Okay, instead of calling the variable X or Y, I should call the variable name, so that everybody knows that that variable is for name. I want to take your age. I should call the variable age, so that everybody knows what the variable is doing. Okay. Then the trick is that avoid abbreviation. You will forget what they mean. Okay. After a while, you forget. So avoid abbreviations. Then be consistent. Okay. If you are using all lowercase or all uppercase or a particular kind of special casing, use that casing. Do not change it midway or during something else. No, use that particular type or kind of casing. Be consistent. Then make sure that you understand that in programming, lowercase a is entirely different from uppercase A. So you don't create a variable called ans, and then later on in your program, you go and call a variable called ans. This one will not work, okay? But you should always use the same case as the original case. Do you understand that? It's very important, okay? Then, like I said, again, variable names must be one word. You must never use two words, okay? So, for example, instead of writing interest space rate, you see two words, you should write interest rate. Okay, so this is acceptable. This is not acceptable. Okay, it's not acceptable because of the space between the characters. In programming, we don't put space in the name of variables. Okay, that is the rule. So you can use various techniques to help you. You can use the camel case where you have all lowercase and then uppercase and then lowercase. Okay, you remember the back of the camel, how the camel looks like. So that's how this one will also look like. Okay, then Pascal, where you have the uppercase, uppercase, lowercase, we call that Pascal case. Then Snake, where you have the meandering case. Okay, so you have that goes down, comes up like that. Okay, so that kind of trick. Okay, then you can have a screaming case or screaming snake case when you want to write constants. Okay, we'll come to that one very soon. And then you can have what we call the kebab case when you are using the hyphen. Okay, if the programming language supports hyphen, you should use the hyphen to differentiate or to distinguish between words. Okay, remember, apart from these two, I don't know of any that allow the hyphen. Okay, then you often hear of the term literals and constants. Okay, so what do we mean by a constant? A constant is a value that cannot be changed. If you can't change the value during the running of the program, we call that a constant. Okay, then a literal is just the value itself. Okay, so when we say a constant literal, it's just the value itself for the particular variable. Okay, now a constant that is associated with a variable, we call that a named constant. Okay, so if I write the number 12 in my program without putting it inside any variable, that number 12 is a literal. But as soon as I put that number 12 inside A, and I make sure that nobody can change the value of A, then A becomes the constant, or sorry, the named literal or the named constant. Okay, so please take note of that. Usually, constant names we write them with capital. Okay, so you have capital E. So this one is called screaming snake case. Okay. So values like pi, remember pi, okay? You will write them out like that in the number. Remember, pi cannot be changed. Okay, so you write it out like that. Then a value called like size, and a value like rate, a value like a particular name you don't want anyone to change. So that's that. Then, like I said earlier, a literal is just the actual value that you assign. So, for example, if I write a variable a, I set the number 12. 12 is the literal constant. Okay, because 12 is an integer, 12 is an integer literal. Okay, but a is a named constant. Okay, so we can write constants as what? Strings, as numbers, integers, as base 8 numbers, we call that octal literals. Base 16 numbers, we call that hexadecimal literal. And then floating point numbers, and then characters. Okay, so character literals. Okay. Then briefly, let me just took this in. I know we don't have enough time, but I want to took this in so that we all understand. During the course of understanding or going through our programming, your friend asked even about the string and the character. So I thought it important to differentiate between the two, or help us to understand what a data type is. Okay? So basically, because we are human beings with very high IQ and understanding about some things that computers don't understand, when I tell you my name, that my name is Bernard, your brain understands that Bernard is a sequence of characters in the English alphabet. Okay. Oh, my screen is off. Hello.
Yes, sir. It's off.
Yeah, it just went off.
Yes, sir. You can hear you,
My
sir.
screen is off.
Yeah, it's off.
Oh. Can you see it now?
No,
No,
sir.
no, sir.
No, sir. Yes,
Okay,
sir.
yeah, I think it's
You
okay.
can see now.
Okay. Okay, thank you. So data types are, how do you call it? Data types are the kind or describe the kind of data that can be stored in a particular variable. Okay. So for example, like I was saying earlier, your brain knows that when I say my name, Bernard consists of about 6 or 4 characters. Okay, when you put it together, it forms Bernard. Your brain knows that when I say 12, 12 is a number. Your brain knows that when I say true, true is a Boolean, true or false, okay, and the rest. But for the computer, we must train the computer, or we must help it to understand the kind of information we are trying to put into a variable. And so that is what the data type does. It tells the computer the kind of information we are putting into a variable. So there are some main categories of data types. We have the primitives, we have the composites, and then the user defined. When we say primitives, we are talking about the most basic type of data you cannot break down. So for example, if I say the number 12, 12 is a number. You cannot break 12 down into any other thing or two subsequent data types. Okay. Then we have maybe things like decimal numbers, things like characters, things like true or false. We call it Boolean. Okay, these ones are all examples of primitive types. Then when we say a composite types are composed of multiple primitive types. So for example, if I'm going to the market to buy some things, every item that I list, for example, tomato, I will add the price of the tomato. If I go and buy maybe garden eggs, I'll add the price of the garden eggs. Now look at it carefully. The name of the garden eggs is a string. Okay, so the name of the thing, so for example, tomato, okay, is a string, okay, but the price, maybe 12 cedis, is a float, or what we call a decimal. Okay, in programming we call the decimal float. Okay, then this one is a string. Okay, so something like this which combines multiple types, we call it composite data type. Okay, then user-defined types are ones that allow you, the programmer, to create your own data types. Okay, not every programming language allows that, but most programming languages today allow you to create your own data types. Okay, we call them user-defined types. So I have a couple of data types listed here so that we can discuss them. Number one, we have integer. Okay, so when we say integer, we are referring to what? Whole numbers, negative or positive, but they should not have any decimal. So examples is what I've stated over here. You might notice that 5 minus 40, 42, and 1,000 all are whole numbers, no decimals. Okay, then when we say floating point, we are referring to what? Decimal numbers. In number system, we call them real numbers. Oh, okay, so any number with a decimal point is a floating point number in programming. In programming, we have two kinds of floating points. We have float and double. Then we can have character data type. So character is when we are using single letters. Okay, so for example, if I have question mark, okay, so question mark is a single character. Or if I have the character B, it's a single character. Or if I have A, or if I have 7, or if I have at, or any of the characters on your keyboard are examples of single characters, or what we call character data type. Now, when I put together two or more characters, they form what we call a string. Usually, we differentiate them with double quotes. Okay, so when you put double quotes on the character or anything that you type and you put inside double quotes in programming, it becomes a string. Okay, then when the value is true or false, we call it Boolean. Okay, so true or false are regarded as what? Logical values. Then when we have a list of things, we call it an array. List of things is called an array. So for example, I have Amma, I have Paul, I have Pete. All of these are strings which are put together. We call that an array or a list. Okay. Then when there's nothing, there's data, but it's not, there's no type. We call it a null. Okay. Mr. DK, who's DK? Please ask your question quickly.
Yes, sir. So, with what you just explained, concerning the characters and the string,
Yes.
does it mean when you are writing a string and you are adding the quotes, does it vary from program languages to, like, does it varies in the program language, or is something general? Like when
Oh,
you are
it
writing the
varies.
character and the string, you are supposed to indicate a single quote or a double quote.
Oh, sir, it varies, eh? Hello.
I can hear you, sir.
Yeah, it varies, please.
Okay. All right.
Yeah, so for example, a language like Python allows you to use single quotes even when it is a string. Okay. Okay. But you can also
Yes, sir.
use double quotes when it's a string in Python. Okay. But most of the C-based languages, they are very strict. If the thing is a single character, you must use single quotes. And then if the thing is more than one character, then you use what? Double quotes. Some of the languages too are like that. But generally, because you guys will be doing C++, okay, I will train you mostly on the rules based on C++, okay?
All right. All right.
So
Thank you
in
very
C++,
much.
if the thing is a single character, then you use single quotes, okay? But if the thing is more than one character, then you use double quotes. Okay, sorry. Are we okay? Okay, let me go on. We don't have enough time. Okay, then, so here in the slide, I have some examples to show on the various data types. So because we'll be using pseudocode, and in the future you use C++, I try to teach you both of the syntax like that, okay? Now, in English, in what we call pseudocode, we will write raw like this, okay? Declare amount as int or, okay? Or we can also write declare int amount, okay? Because this one is pseudocode, you can write it any way or anyhow or any style you want based on the rules, okay? So we will write it as this or this, and then in C++ or C, you write it like this, okay? Because in C++, there's no declare, okay? Please note that. So we will use them interchangeably like that, okay? Then floating point, I already explained, is when you have decimal numbers. You can create a decimal number or variable by writing the declare keyword and then following with the name of the variable and then as float, okay? Or like I said earlier, you can write declare maybe, so declare maybe float amount, okay, like that. So whether you bring the float and declare first or the declare and float first, I don't really have any objections. Then in C or C++, you write float amount. So you see the similarities, okay? I hope you see the similarities. You can see declare, you can see the name of the variable, and then you can see the data type of the variable, okay? And the same is said in the C++ or in C or in Java as well, okay? Is that another question? Hello, your hand is up. Is that another question?
Yes, please.
You let me finish.
Hello?
Let me finish this lecture, and then let me finish this slide. Else, we will not be able to finish the slide, okay? And then I'll let you ask your question, okay? Okay, so we can put regular floats. We can put, so what you are seeing over here is 1.8 times 10 raised to the power minus 2, okay? So when you want to write something like this, we write it in scientific notation, okay? Then this is 7.9, times 10 raised to the power 3, okay? So this one is this, and then that one is that, okay? Then character is when you want to create a single character. So you can just say character answer or declare grades as character, okay? Then when you want to initialize them, you can just write them like this, or what you're seeing down here, or any of this or that as well, okay? Then Boolean is when you want to put true or false in a variable. So you declare it as Boolean. So bool is present, or you can write, if there are more than one, you can separate them with what? The comma. And then, so declare, okay, that's also there. And then you can also write this like this as well. When you want to put the value or initialize the variable, is visible, okay? So anytime you perform any operation like this with any of the less than or greater than or equal to, less than or equal to, equal to, not equal to, right? Okay, so you guys know about this guy, and then this guy, and then this, and then this, and then this, and then equal to, okay? In programming, we cannot write this directly, okay? So we write greater than or equal to like this, and then we write less than or equal to like that. And everybody knows about this. We cannot write this, so we write not equal to, and then this one we write as equal to, okay? So this is how we write them in programming. These ones are still the same thing you see in programming all the time. Okay, so whenever we use any of these, we get true or false. Okay, so please note that very well. Then string is when we want to store more than one character, like someone's name, like a word, a sentence, more than one sentence, one paragraph, those kinds of things, we use string. Okay, so you have to declare the string, or you can declare and put something inside the string. Okay, then when you have one data type, for example, you have something as an integer, and you want to turn the integer into a decimal, you do what we call typecasting. Typecasting changes the data type from one to another. Okay, so you can change this from int a equal 2 to by quickly changing it. This one will cause a to become 2.0. Okay, how do we change it? We just put the data type inside the bracket in front of it like this. Okay, so you put the bracket and then you put the data type you want to convert. Remember, a is an integer, so if you want to change it into a decimal, you have to put the float into the bracket and then in front of a, and then once you do this, a will change from being an integer into a decimal. Likewise, if we have a decimal float b equal 5.7, the moment you do int b, what has happened is that the 5 is the only one that is going to 5 is the only one which is going to be represented. Okay, it's going to remove the decimal number. It will not do rounding. Typecasting does not do rounding of the number. It removes the decimal number completely. Okay, so please take note of that. Okay, so I have some examples here to show you. For example, if I have the number 12, which is an integer, if I do float 12, then you get 12.0. If I have a number 15 divided by 2, remember, I should get 7.5, okay? But when you do two integer, when you calculate the division of two integer numbers, you are also going to get an integer because 15 is an integer and 2 is an integer. So the result will not be 7.5, unfortunately, okay? But if you want to force 7.5, then you have to convert one of the numbers into a decimal. Okay, so here I force 15 to become 15.0 before you get 7.5. Okay, then here too you can convert this one into 25 by simply doing the type conversion around the quotes. Okay, so please take note of that. Then sometimes in the programming, you see that I'll use some of these to cause some various different changes. So for example, if I want if I'm writing a quote and I say maybe I want to type Bernard, okay, Bernard's. If I do this, it will not come out the way I want it to come out. It will read a little differently, okay, without the quotes. But if I need the quotes, I need to escape. We call it escape. We need to escape because quote is used by the programming, by the printing. So if you want the quote to print, you must escape the quote by putting a backslash in front of the quote before you see the quote appear in the printing. The quote will only appear when you do the backslash. Okay, so please take note of that. Okay, so these ones I'll come back to it later on, but they are there in your slide to help you understand when you experience something like that. And then when we say a keyword basically is a word which is used by the programming language. Sometimes we refer to them as reserved words. So for example, when you are learning your C++, you will learn that, for example, a word like see out or CN, or a word like main, or a word like int. All of these are examples of words which are used by the programming language. Okay. Yes, the questions. Your question. The gentleman with the question. We can answer your question now.
Hello, sir.
Yes, sir.
Hello.
Yes, sir.
This is my question. About that double quoting. You did mention that.
Can someone hear him?
Oh, sir, we
No.
can't hear.
A quote and then double quote together.
The what?
Hello, sir. Please, can I ask my question?
Yes. Nobody can hear you, so I kindly ask your question.
Please, can you hear me, please? Hello, please, can you hear me? Hello.
Hello, can you hear him?
Yeah, I can hear him now.
Okay, so gentlemen, go on, or your class will end soon.
Yeah, my question is I realized that the integer. You said the integer could be a number like 1, 2, 7, and all that. And I also noticed that a character too can be a 7, 8, or an integer. So I don't know. I want to find out that what's the difference from the integer and then the character. Because I noticed that
Okay.
I thought the character was maybe a single letter like A, B, you know. But I also saw numbers also as part of the characters. So I wonder whether the integer and the character are a bit same or something.
Okay, so very well suited question. The difference is that characters cannot be used in calculation. Okay, but when you declare an integer, you don't put quotes around it, so you can use it in the calculation. But as soon as you put quotes around the character, single quotes, you cannot use it in calculation. Every character on your keyboard, whether it's a number or a sign, a symbol, or a letter, is a character. So you can write each of them as characters. Okay. But you cannot use them in calculation. The moment you create them as character, you cannot use them in calculation. You have to convert them into an integer. So integers are the numbers without the quotes. Once you declare a number without the quotes, an integer, but you cannot put a character into an integer. Okay.
Hello, sir.
Yes, sir.
My question is it possible to have different variable with the same name?
What do you mean by principle? I don't understand.
Different variables with the same name.
Can you come again? You want to write multiple variables and then you want to use the same name?
I'm asking if that one is possible.
Oh, in most programming languages, no. Once you create the variable, it has been created. For example, if I say int A has been created. If I say A equals to 2, 2 has been put inside A. If I say A equal to 3, now the 2 has been changed to 3. So the computer only sees 3, not the previous 2. If I say A equal to 5, Now the 3 will be changed to 5. So the computer now sees A is equal to 5. You can change the value of variables. But if you try to declare maybe int A, int A, int A, only one of the int A, the first one, will be accepted. All the rest will be wrong. Does it help you?
Yeah, okay, sir.
Okay.
Hello, sir. Hello, sir.
Yes, sir.
Hello.
Who am I talking to?
Sir, please. Talk me.
Okay.
In the sixth slide, I saw you describing a double data type.
Hold on.
I
Can
saw
someone hear him? Hold on. Can someone hear him?
Yeah. Yes, sir.
please.
Okay.
Yes.
He sounds to be like
Yes, sir.
he's in a room somewhere. I cannot hear him. So kindly, okay, gentlemen, go on. They will listen and then tell me what you are saying. Okay. I cannot hear you.
So in the sixth slide, sir, I saw you describing 7.5 as a double data type. Meanwhile, in the explanation, said decimal numbers are described as float data type. So I want to know why you describe 7.5 as a double data type, but not float data type.
So someone tell me what he said. I did not. His audio is so bad. I cannot hear what he's saying.
Okay, sir. So he was asking that in your discussion, you said 7.5 is a double data type. And also, you also mentioned that we use floats for decimal places and something like that. So what is the difference?
Oh, but I did mention that there are 2 kinds of decimals in programming. We have the double and we have the float. Okay, so I did not contradict myself. I'm saying that there are 2 kinds of decimals. We have the double and the float. The small ones are called float, and then the very big ones are called double. That's the key difference. Okay. Usually when we say float, we are talking about decimal values whose decimal points are only accurate to 7 decimal points, okay, or decimal numbers after the decimal digit, or sorry, decimal point, okay. And then for double, we are talking about 15 decimal places, correct? Okay. So we will see a couple of them very soon. Okay. So when you want to store a very large decimal number, which has a lot of decimal numbers after the decimal point, you use double. But if it's a very small decimal number with very few digits after the decimal point, you use float. Okay. Did you get me? Okay. Any
All
other
right,
question?
sir. So my question is not really close to what we are discussing here, but I just wanted to ask. So I wanted to know if maybe there could be a link you could share to us, so maybe you could get the software, the C++.
What software?
Yeah, like
What
we
software?
should get it. The software for the programming, please.
Oh.
Or maybe we could just get it on our own.
No, I've not taught any software. I've not taught any software.
Now, I mean the programming languages, please, if maybe I'm confused.
And I've said I've not taught any programming software here. I have not. When I do, I will show you where to get things from. But for now, I have not. And I don't want to confuse anybody, so I will not share anything for now, okay?
All right, sir. Thank you.
Okay, you know, sometimes some people understand things differently when you try to help. Okay, so I want us to just follow the course, go to the LMS, do the work I put over there every Monday. Just go there. By Monday, I'll open. You see, I have 2 classes taking this class. Sorry, this class. So by Monday, I go there. and then I change some things and then set up a small assessment for you. So every Monday, go there, do the assessment, check the slides, anything, just follow along, okay? But don't, if you preempt, even in the course outline, I didn't state anything I'll ask you to download. So don't worry, don't download anything yet, okay? There will be a course that will teach you C++ in the future, not now. So hold on, and then gently let's learn the basics, okay? I don't want to preempt anything. Mr.
Hello,
Alfred.
sir. Yes, sir. Sir, please, I want to ask if, let's say, a simple question is ask, what are variables in programming? Can we say they are like a files or folder? Maybe forget like container.
No. They are not folder. I said they are
Okay.
container.
So
Container,
okay,
where
container.
information is kept in memory.
Okay. Thank you.
They are not a folder.
Okay.
Variable is not a
Thank you.
folder. Okay.
Okay. Thank you.
Yes, you're welcome. Yes. Also, so in the absence of any question, I will leave you be so that we can attend to other classes. I have another class, and you also have another class coming up. Thank you very much. I'll see you, God willing, next week. Godspeed, and please check the LMS for all the updates. The course outline, the course slides, everything I'm doing is on the LMS. So please follow along, okay? Thank you. Bye-bye.